Hi, this is Ari Lamstein, and I just wrote this new blog post, new release, COVID Demographics Explorer version 2. This post is kind of long. It's definitely on the long side of blog posts for me, and a few people asked me to record a walkthrough of it because they uh, prefer to absorb new information through video and audio than reading it. And so I thought I'd give that a shot. This is totally new for me. And if you like this, please leave something in the comments so I know, and I'll do more of them in the future. As I said, the title of this is New Release COVID Demographics Explorer version 2. And so what is this COVID Demographics Explorer app? Well, let us click and find out. This is an app that I created last year to help people understand how America has changed since COVID. You can see here there are 3 drop downs. You can select the state you live in, the county you live in, and a demographic statistic that you'd like to see. And my hope is that you'll actually pause this video and visit the app right now, census-explorer.streamlit.app, and enter your own county so you can see how it changed. The initial version of this app had this graph on the left that shows you time series data of the selected demographic for the selected geography. The app defaults to San Francisco County, California, because that's where I live. And you can see here that this dashed line indicates that data is missing. There was no data published in the American Community Survey for 2020. But you can see pre-COVID, there was generally an upward slope in population and then this huge, sharp population drop. And a lot of the time when I show this to people, my neighbors and my friends in San Francisco, they'll say it looks like a sharp drop, but hey, maybe it's percentage-wise, it's very low. Or they'll also say a lot of big cities lost people during COVID. San Francisco isn't nearly as dramatic as you're making it out to be. And I really wanted to address both of those points. And I spent a lot of time trying to create a single visualization that would answer both of those questions, which is the first being, what is that drop on a percentage basis? And how does the drop that San Francisco experienced compare to other counties? And what you see on the right is my attempt to answer that. This type of visualization is called a swarm plot. It is actually my first time creating a swarm plot. And what you can see, this reddish orange dot is San Francisco. In this plot, the x-axis indicates the percentage change. Each dot represents one of the counties in the data set. There's 863 of them, I believe. And the selected county is highlighted, and that's San Francisco County. The y-axis is actually meaningless. The only reason why any of the dots moves off of the y-axis at all is to prevent overlapping. And so at a glance, you can see that San Francisco County is the 3rd largest drop of all the counties in the data set. So that 8% population drop we have is actually pretty unique among counties, which is what I wanted to convey to people who live here. And when there are a lot of counties on the y-axis, what you can see is that's just where a lot of the data tends to fall. So most of the counties experienced either no population change or looks like between 0 and 10% is normal. If you were curious about this one outlier here, there is still a table tab, and the table is sortable. So we can see that Kaufman County, Texas had an increase of 36%. And that is surprising. I've never heard of Kaufman County, Texas before. But on the other hand, it's not that surprising that a low population county had a large percentage increase. And you can see Kaufman County, Texas in 2019 had a population of 136,000. This data set, I should say, is the American Community Survey 1-year estimates. So it only includes counties with a population of at least 65,000. And there's also Map tab if you want to see the geographic distribution of the values. Going back to the graphs, I want to point out that I find this pairing to be extremely powerful. And so I want to give just one other example of that. If we select the count of the number of people who work from home, you can see that San Francisco had a very large increase in the number of people who worked from home during COVID. But that change is actually pretty normal amongst all the counties in the data set. You can see the values right there in the middle. And that's what I want to say about the visualizations or the changes to the app from the user's perspective. If we go back to the post, though, you'll see I made a number of technical changes. And a lot of people read my blog hoping to improve their technical skills. So I wanted to go through these both in my blog and also in the video companion to the blog post. The first was about Census integration. I've worked as a software engineer, data scientist, trainer, and so on for too long now, but I still consider myself a bit of a newbie when it comes to Python. And last year, I took Matt Harrison's professional Python course to help me learn and improve as a professional software engineer in Python. In 1 week of his course, he introduced me to this world of linting in Python, tools like Black, Flake8, and Rough, which you run on your code base and it helps you conform with industry standards for how people code in Python. That was interesting to me, and we set up GitHub Actions to automatically run those tests on every pull request in a repo. After that course, I started contributing to the Census Dis package, which is the package that my app uses to get data from the US Census Bureau via their API. And the maintainer of that package actually uses Black, Flake8, and Rough with GitHub Actions to run tests on code quality for pull requests. And so I thought, well, why don't I set that up for my repo too? And it's actually super easy. If you're interested in that, you can click this link to go to the file lint.yaml in my repo. You could probably just copy and paste it to the exact same location in your own repo, .github/workflows. And then you'll have to click this Actions button to turn on GitHub Actions and run it. Overall, I found it very easy to do, and I enjoy improving the quality of my code, and this seems like an industry standard way to do it. And so I've been happy with it so far. The other change was migrating my project from pip and requirements.txt to UV. For those of you who don't know, well, I assume everyone who's watching this knows that pip is the general way to install packages in Python. But some of you may not have heard of UV, which is this newer, faster way to manage dependencies in Python. This is also something I learned in Matt Harrison's professional Python course. And so the initial version of this package was created before I took that course, but now I decided to just port the package over to UV. I am amazed that at every meetup I go to, people are always talking about UV. And so this seemed like a great way to get practical hands-on experience with it. If you are interested in learning more about UV, you can visit the developer tab, the developer file in my repo for this project. And I have these installation instructions in case you wanted to modify the code. My hope is always that this project is a starting off point for someone else to do a more interesting analysis than I've done myself. And if you want to do that, you'll need to clone the repo, install UV, which is very simple to do. This is the official documentation. It's literally a one-liner on the console. And then you'll need to type UV sync, which will create a virtual environment with the project's dependencies in .venv. And then you type source.vm bin activate like you normally would. And then if you can run the app with Streamlit run streamlitapp.py, then it worked. The number of files in this version increased quite a bit, and I decided to create some directory structure to make the code base a bit easier to work with. One of the surprises was that in Python, it's a bit hard to import a file from the line above, from the directory above. The first language I ever programmed in was C++ professionally, and we would just type #include ... whatever to do that. The next language I programmed in professionally was PHP and then R, and they all followed that same convention. Python is different. I spent much too long banging my head against the wall, and I finally wound up on this Stack Overflow, which helped me solve the problem. You'll note that it has 2.1 million views, which I take as proof that I am not the only person who has had this problem. And my favorite comment on this whole Stack Overflow question is this, which has 115 upvotes. It says, "This is an infuriating amount of complexity to add to accomplish something that is done so trivially in a language like Node.js. I have yet to program in Node.js. Hopefully one day." And then the last sentence I also really liked. The fact that we even need a dunder init.py in every directory is so silly. It's hard to believe it's real when you first learn of it. That really cracked me up. On my post, I quote the GitHub commit message that I did when I solved that problem. And I basically worked around it because I think that that's the way that Python wants you to solve the problem. And I'm not going to read through it here, but it's there in case anyone wants to do a deep dive into that. The last technical change I made was a migration to Census Dis version 1.4.0. I mentioned earlier, after taking professional Python last fall, I started contributing to the Census Dis package. First, just fixing open bugs. And finally, I created my own module. It's in I have a separate blog post about it called Multi-Year, which makes it much easier to do this type of multi-year trend analysis that is in the app that I showed you, the COVID Demographics Explorer. And I also did a deep dive into immigration, how immigration in my hometown changed over the course of the American Community Survey. That's where I created a module for it, and I upgraded this app to use that version of it. And the data generation script, I think, is now just so much easier to read. It's much shorter and, more importantly, just so much easier to read. The key part of the multi-year module is this function, download multi-year. This is a good example for it here, the DF post 2005. If anyone wants to understand where the data comes from or how to modify it, this is the script to look at. And then I just ended with some closing thoughts. The purpose of this app is multifaceted. It interests me what the app says about my hometown, and I hope that someone out there visits the app and enjoys learning about how the demographics of their hometown has changed during COVID. And I also hope that it inspires someone to use this code base as a starting off point for their own projects that interest them as well. And if you do that, please visit my website, click on the contact page, and drop me a line. And if you like the app, please give it a star on GitHub. Thank you very much.